We have a fun exercise in this guide. Now this one's going to be a little bit longer than most of them, and it's because we're going to build a non-trivial kind of feature, and that is we're going to build a prefix notation calculator. As you probably know, a normal calculator looks something like this, where we can add 2 plus 2, and if we run this, this will equal 4. Now, that's fine for 2 items, but what if we want to add other ones? So what if we want to add plus 5, plus 1, and then plus 1? If we run this, then we'll get the answer 11, but we had to type in 4 different plus signs. Well, what we are going to build is a calculator where we can actually get rid of each one of these extra ones, and we can just add one at the beginning. This is the exact opposite of a Polish or reverse Polish notation calculator where the operator would go at the very end. And the difference is really not a big deal. We could have done it as well, but I've seen a bunch of different tutorials that show how to build that. So I figured we might as well switch it up. But if you need to build a reverse one, then you can take these processes and essentially flip them around. So that's what we're going to be building, but that's only one part of it. We also are going to have the requirement of managing errors. So if you look down on, say, line 36, you can see that the expectation is that if we pass in a non-valid operator, we're going to get an error, and the error message is going to be very explicit where it says operator is not valid, needs to be, and then it lists off the 4 different types of operators that are allowed. Now, if you come up to the test right above it, it returns an error if the correct set of integers are not provided. So in other words, right here, if we pass in the letter B, this is not going to work, and this needs to also give a message, and it says values need to be integers. Now, if you've ever worked on a Rails application or something where you saw some very explicit error messages that not only let you know that something was wrong, but also what the problem was, that is a custom error handler. So that's why I wanted to build into this is not only the Polish notation calculator, or prefix notation calculator, I think you're going to see that this is actually very straightforward to build. The more complex part is going to be the validations and the error management. So there are a number of ways that you could build this out. You can see the method needs to be named PM calculator, and it takes one argument that is a string. So we have a couple different things that we need to do here. Well, when it comes to breaking this down, let's first just say that we have and we'll call PN calculator, and then I'm just going to grab some of these values. So I'm going to say plus 0, plus 5, plus 1, plus 9, plus 11. And what we want, obviously, is for that to equal 26, which is the correct answer if you add those all together. So the first thing that we need to do when it comes to solving this problem is we need to be able to know the difference between the operator and the values. Now, if this is entered in properly, then the operator is always going to be at the very front. So first thing that we're going to do is say values and set this equal to string.split. And so we can run this, and you can see that we now have our correct item. So this is now an array of strings with the operator being at the beginning. I'm going to create another variable. So it's going to be operator dot and then values dot shift. And this is the shift method is a helpful array method that's actually going to come to this array, and it's going to grab the first value. It's going to remove it, and it returns it so it can be stored inside of this variable, but then it has a effect where it will also pull it from the value array. So it's not like we are grabbing the value and then we have to go delete that one. By calling shift, it pops it off, and then it stores it inside operator, but values is permanently affected so that it gives us exactly what we need. So if I run this code, now we can see that we have access to our correct operator. And just to show you that this does work, if I return values, this is going to return our set of values without the operator. So this is exactly what we're looking to do. Okay, so that is that part of it. Now let's talk about how we can perform our processing. Well, if I call a very helpful little method called eval, then this is going to evaluate anything inside of it. So let me just give you a little bit of an example. So if I say eval and then say 2 plus 2 as a string, so even though this is a string and normally this would just be treated like a string, eval actually processes this. So now this is equal to 4. Now one caveat, so no one can say I didn't warn you, eval is something you have to be very careful with. It's incredibly powerful. Essentially, it will evaluate anything you pass to it, and because of that reason, it's a great tool to use. But you have to be very careful, because if you were to let a regular user pass anything to eval, then you're going to potentially run into a malicious situation. You could have a hacker pass in something that wiped out a bunch of data or perform some kind of nefarious act. So you need to be careful. For our purposes, this will work perfectly fine. And if you're doing this for a coding interview, just give them the same exact caveat that I just gave you. This is a great way of performing this task, but you'd have to make sure the data obviously is cleaned up and not accessible, so no user directly can call eval there. But that's what we need. And the cool thing is, if I add another one just like this, then this still works, and so this is going to equal 6. So essentially, what we need to do is we need to take our values, which we know are all these items here, and then we need to take the operator and then slide it in between each value. So how exactly can we do that? Well, there is a pretty straightforward way, thankfully, and that is what we're going to implement here. So I'm going to say eval and then say values dot map, because one thing that we have to do is we need to convert each one of these items to a float. And the reason for that is because if you come down and come all the way down to our division section, you can see that anytime we have division, we need to return a float value. And it's because if you said, for example, right here, 10 divided by 200, this is going to need to be a percent or a decimal. And so we need to convert each one of these on line 7 to a float, which we can do with the ampersand block syntax. So I can say to float. And then from there, this is going to be a pretty cool thing. We can call the join method and pass it in the operator. So what exactly is this going to do? Well, join, if you remember, is going to take an array, and then it's going to slide any argument we pass inside to it in between each element. So a very common way of using join is to pass in something like a dash or a comma to take all the array elements and simply list them out in a single string. Well, right here what we're going to be able to do is to slide in our operator so that it does something like this. It would do the equivalent of, say, 0 plus 5 plus 1 plus 9 plus 11. So this is what it's going to do, and then that is what's going to be evaluated. So I believe that this should work. So if I run this, you can see that equals 26. So that is working perfectly. Now, this is working perfectly, and it would actually cover the test cases for test 1, 2, 3, and 4. But we're not quite done, because if we throw in a bad piece of data, which is definitely a possibility, so, say we put in, instead of the operator first, we put a this number, we put a plus followed by these numbers, and if I run this, we're going to get an error, and it's a syntax error because it tried to essentially convert that operator into a decimal, which is not going to work very nicely. So we can't let this happen. So we're going to have to perform a few little fixes here. And the fix is not with the implementation. The fix is actually with some validation. So the first thing we need to do, looking at the test, is we need to make sure that all the values are integers. So I'm going to say values are integers. And that's going to take an array. So that's just going to go through an array, and it's going to either be truthy or falsy based off of what gets returned. Then I'm going to say operator is valid, and that's going to take an operator, and it's going to simply return true or false depending on if it's valid or not. And then the other thing, remember down here at the bottom how we have these cool custom error messages where it says that values need to be integers and an operator is not valid. Well, there's a few ways we could do that. We could have some kind of long conditional that checks inside of each one of these, but that's really not the best way of doing it for a Rubyist. Instead, what you'd want to do is create a error handler, a custom error handler. So I'm going to say class pn error, which stands for Prefix Notation error, and this is going to inherit from standard error. And now inside of this, we are simply going to give a custom message. So I'm going to say def initialize, and we're going to give a default. So it's going to say pn error, and then inside of it, just call super message. Now, if that is not very clear to you, this actually doesn't have anything to do with the error. This is just pure Ruby. So we have an initialize method. We pass in a default argument for the message, and then we pass it to super. So what super is going to do is it's going to look at the initialize method for standard error, and then it's going to pull that back. And so what we're going to be able to do is to actually pass in, so it's going to call an error, and then we can pass in a custom message whenever we need to. And this is going to be how we implement our validations. So now with that in place, let's go through and build out our integer check and then our operator check. So there are a number of ways that we could check to see if the values are integers or not. And so I'm going to say array, which is our argument, map, and then pass it a block. Now inside of this block, what I want to do is return false if, and now I'm going to pass in a regular expression. So I'm going to say I matches, which I'm going to use the equal and then a little tilde here, 0 to 9. And then say if that is equal to nil. Now this may seem a little bit confusing, and it's because we're switching between true and false a few times. So it's important to understand exactly how this works. So let's actually come, and I'm going to create a little test array here and call it 1, 2, and 3. So each one of these values, and actually I need to remember these are going to be strings at the time it's looking at it. So let's replicate that. So it's going to essentially say, are these numbers or are they not? And so if I run this exact code, so let's not even get into the values or integers part. Let's just call exactly what we have here. So I'm going to just copy this, bring it down, and let me just switch this out for our test array. So right now I'm just trying to see exactly what processes are occurring here. So now if I run this, let's see exactly what happens. It iterates over 1, 2, and 3, and then because these are each values, so each of these do match 0 through 9, it matches false, false, and false, and then it returns an array. Now remember, in Ruby, if it returns an array, even if it returns an array of nil values, this is still going to be true. So in other words, this is saying that if we ask the question, are all these values integers, then this is going to read as true to Ruby. And the reason is because it couldn't find any spot where this was not accurate. Now we could also change the language up a little bit to, flip it and say return true unless, and, then it finds a value. That's completely up to you if you want to change the logic, but this is doing exactly what we need it to do. So if I were to come in here and put an operator in, which is one of the items we want to check, now notice right here that this gives us a error. So this gives us 1, 2, and 3, and then it returns false because local jump error, unexpected return. Oh, and this one, it's going to do this because it shouldn't have an error. Or it should never return. Return's only used inside of methods. Now if I run this again, now you can see that this now has not just a regular value, not just a nil, but it actually has a straight false, and it has a false right here, not just a nil value. So this should give us what we're looking for. So I'm going to get rid of this. And how would we implement this? Well, inside of our method, I'm going to start a begin rescue block. So I'm going to say begin and say raise pn error dot new, and we can say values need to be integers unless values are integers. So, and this is passing in the value. So essentially what this is saying is I want you to raise an error unless all of the data is good. So if the data is bad, then you don't have to, then you do raise an error. But if it's good, just skip this entire step. And then we want to rescue this. So I'm going to rescue the pn error and pass in this and just say return E. So this is another way, like I said, it would be completely possible for you to do conditionals such as if else, but I personally like this syntax whenever we are working with a very specific set of errors that we may run into. Now let's actually test this out. So I'm going to say hit save. Right here on line 32 is where the output should be. So I want to first make sure that this is actually working. So this is working for our normal base case. But now what happens if we switch this up? Because we're checking to see if these are integers. Let me change this out to be the letter G. Now if I run this, there you go, look at that. It no longer is throwing an error. It's not stopping anything, or I should say it's no longer throwing a confusing error. Now it returns an error. It returns the right kind of error, and it says values need to be integers. So this is exactly what we want. Notice how much more helpful this is than that weird syntax error that we got before we implemented that. So this is the first part. Now, if this was a little confusing, and don't worry if it was, because one of the more confusing things, especially for new developers, is when things switch between being true and false and trying to ask questions, such as saying, I want you to raise this error unless the values are integers. But if so, go through it a few times, play around with it, try out the code and make sure that it matches and you see the data flow and you see how the values change, which items are being checked, that kind of thing. So values are integers, that's the first one, and that's probably the one that's a little bit more challenging. The next one is we just need to make sure that the operator is valid. So in this case, I'm going to create an array. So I'm going to create an array of all of the operators that are valid. So another way of creating an array of strings in Ruby is by using the %w. And now I can just list these off. So I can say plus and minus, the multiplication, and than this. So now if I do that, what I can say is include operator. Now, if you've never seen this kind of syntax before, let's just test it out. So I'm going to say operator is valid, and then let's just pass in the multiplication symbol, which is an asterisk. This should return true, and it does. And now let's test it out. If I put in the letter F, and I have to finish it off. If I put this in, this should give us false, and it does. So this gives us a good check to make sure that the operator is one of the valid ones that we will allow. So if so, now we can come up and pretty much copy this. We're going to change the values. Sorry, we're going to change the error message. So here I'm going to say operator is not valid, needs to be plus, minus, asterisk, or the division symbol, the slash. And obviously we also need to call the right method. So this one's going to be operator is valid, pass in the operator. Okay, now let's test this out. We have line 33 here, and this one still should work, so everything's still working on that side. Now let's make sure that it's working for just regular when someone enters it in properly. There we go, that's working. And lastly, let's verify that if someone throws in, say, the wrong, like a number or anything like that, this should throw the new error, and that's it. Operator is not valid, needs to be plus, minus, and that gives us exactly what we want. So that's exciting. Okay, so I'm going to save this and open up on the right-hand side. And let's run all of the tests. So I'm going to say rspec. This is March 24th. Now if I run this, look at that, 6 examples, 0 failures. So we have successfully built out a prefix notation calculator that one does its job. So when all the data is right, it does its job. But then when a user tries to enter in anything such as the wrong set of values or an operator that's not valid, it not only throws an error, but it throws a custom error, and it won't process, and it does exactly what it is supposed to do. So this is working very nicely. Good job if you went through that. I know that was a little bit of a longer exercise, but this is a very common type of interview question, so it's a good one to practice, and it also teaches you quite a bit. We not only learned how to build a prefix notation calculator, we learned how to build a custom error handler, and then 2 different types of validation Boolean methods. So very nice work.